All right, here we are looking at number 19 from section 5.2 about the roulette wheel. So we says here that a roulette wheel has 38 numbers, 1 through 36, 0 and double zero. Half the numbers from 1 through 36 are red, the other half are black. 0 and double zero are green. So we have a wheel here, so we can see that we have 38 total spots. And we can see the red, the black, the green, all of that. A ball is rolled and falls into one of the 38 slots, giving a number and a color. The payoffs or winnings for a $1 bet are as follows. So this $1 bet tells us that if we lose on our bet, we are going to lose $1. So that'll come in handy when we make our probability distribution. So we have the various outcomes. This is our possible winnings here. And we're told that a person bets $1, find the expected value. So for the part A, we're looking at red. So we bet $1 on red. So let's make a probability distribution for that. We'll let X be our winnings, how much we walk away from the table with, how much our profit, our net profit here. So if we bet $1 on red, let's label this. Here's our win and here's our lose. We win $1. That's what it says. For red or black, we win $1. We will be using this value here. And if we lose, then we are minus $1. So then what's the probability that we win here? Well, how many red slots are there? It says here half of the numbers from 1 through 36 are red, which means there are 18 reds. So the probability of winning, of landing on the red, is 18 out of not 36, but remember there are 38 total spots. So it's 18 out of 38 is the probability that we're going to land on a red. So that means the other slots are going to be losers for us, and that's going to be 20, because 38 minus 18 gives us 20. So now we can calculate our expected value, which is just the mean of this distribution. It's the sum of each x times the corresponding p of x. So we have 1 times 18 over 38, the probability of winning, plus negative 1 times 20 out of 38. And if we evaluate all that out, that gives us about negative 0.0526. Now this is round that off and say negative 5.26 cents. So since our expected value is negative, we expect over time to lose money playing roulette, and that's how the casinos make their money. So that's part A. Let's look at part B now. So part B, we are looking at betting on an even value. And we're going to follow the same procedure. We're going to make a probability distribution for winning and for losing. We'll use the same columns there. So let's take a look. If we bet on even or odd, we are now, well, we still get $1 if we win. So our possible winnings is $1, and we can lose negative 1. We can get negative $1 if we do not land on the even or odd that we bet on. The probability, how many even numbers are there? Well, in roulette, the numbers at the top and the bottom, this 0 and double zero, these guys here, we'll mark them in green. Both of these do not count as even or odd. So for all of these, we're only for this bet, we're only considering the 36 values from 1 through 36. Half of them are going to be even. So the probability of winning, if we bet on even, is going to be 18, which is half of the 36 values over 38 total slots, which means the other 20 of the 38 are going to be losers. Our expected value, notice our probability distribution is the same. So our expected value should be the same, negative 5.26 cents. So betting red or black versus betting odd or even, they have the same expectation in the long run. So part C, now we're betting on the value double zero. So our distribution should be a little bit different this time because we get more money if we win. If we win, let's find 00 on here. 00 is right there. If we win, we get $35. If we lose, we're still out $1. That was our initial bet. But this time the probability is different because we look at how many 00s there are. So there's only one 00 here because the single 0 at the very top of the wheel does not count. So our probability of winning is then 1 out of 38. And the probability of losing is now a whopping 37 out of 30. Not great odds. So we can calculate our expected value for this bet now. We're going to calculate it the same way. We multiply each x by its corresponding probability. 35 times 1 over 38 plus -1 times 37 out of 38. And that gives us, if we evaluate that out, interesting, negative 5.26 cents. We can start noticing a pattern here. So let's look at D. D is betting on any single number. For example, if I walk up to the wheel and I bet on 31 or 19 or 17 or whatever single number you like, we know that the probability, or the winnings when we bet on any single number is $35. So we can make an expectation table for that, a probability distribution. We win, how much was it? Any single number is $35, so we can get $35, or we can lose $1. The probability of landing on our any single number, if I pick any single number, well, there's only one copy of every number on the wheel. There's only 130, there's only 111, only 17. So we have a 1 out of 38 chance of winning, and the other 37 slots on the wheel will be losers for us. And we notice that just as the red and even probability distributions were the same, the 00 and any single number probability distributions are the exact same. So our expected value comes out to be negative 5.26 cents. We don't even need to really do the work since our distribution is the exact same. So we have one more to look at, and it's betting on 0 or 00. So in this case, now we have two numbers we could bet on, and our winnings will be $17. So let's take a look at that. E, 0 or 00. We can make our probability distribution. If we lose, we're out $1, just as before. But now if we win, we get, how much money was it? $17 for winning on 0 or 00. So what's the probability of it? Well, 0 or 00 corresponds to the two green slots on the wheel. So we have a 2 out of 38 chance of landing on those. So that means the other 36 out of 38 are going to be losses for us. So now we can calculate our expected value again. Notice it's not the same distribution as any of the previous ones, so we can actually do it out. 17 times 2 over 38 plus -1 times 36 over 38. And we evaluate that out, and if you were able to guess, we get negative 5.26 cents. In fact, any bet on the roulette wheel, aside from, I think, maybe one special case bet, has the same expected value, negative 5.26 cents in the long run per dollar. So roulette is a well-designed game in that there is no best bet. All the bets are equally bad, you can say. But that's how we calculate those expected values.